Hi, my name's Alex Andon, and this video is about composites in electric vehicles. To begin, let's start with a brief introduction. In the automotive industry today, composites are mostly used to reduce weight while maintaining or increasing the structural properties given with traditional materials. This is a great advantage in typical combustion engine cars, as decreasing the weight increases the fuel efficiency of the car. Electric vehicles are newer and increasing in market share year after year in the automotive market. Some uses for electronic vehicles are weight savings through part replacement and consolidation, which increases the range and decreases potential fuel cell size of the cars. Also, specific battery enclosures for the much larger batteries that are found in electric vehicles. There are also potential for structural features that can hold an electrical charge for electric vehicles. Now let's take a closer look at some of the design concepts for which composite parts can have a great positive improvement on electric vehicles. To begin, structural part replacement, like replacing metal parts, which are typically heavy with composite parts, can have a great weight savings, which can therefore increase the fuel efficiency and maximum mileage of electric vehicles. Another key component that can be improved with composites is battery enclosures. In electric vehicles, the casing around the battery packs needs to be much larger. This becomes important because of the added weight and risk from the larger batteries in electric vehicles versus the small battery in combustion engines used to just start the engine. Composites can address several key issues with the battery enclosures, such as a significant reduction in weight and increased environmental resistance properties. An example of a battery enclosure can be seen on the top right picture. Structural features that can store charge are also another promising feature of composites in electric vehicles. Multifunction composites that provide both structure and can store electricity have a lot of potential to replace many of the different parts involved in current electric vehicles. They could even eliminate the need for bulky battery packs and casing altogether. The picture in the bottom right shows the latest advancements in multifunction composite technology. For the casing of the large battery systems in electric vehicles, there are several important performance requirements that need to be fulfilled. The battery packs must be adequately protected, as they are a critical system within the cars, but also one of the most volatile. These casings must be strong in order to hold up to both normal use within the car and in order to protect the battery during crashes and malfunctions. Additionally, these cases need to adhere to strict fire, smoke, and toxicity requirements in case of a malfunction in the vehicle. The battery enclosures also need to provide environmental resistance, such as having a large amount of thermal insulation for the batteries to operate at a normal temperature, as well as keep out water and insulate from electrical fields. For structural batteries, it's important to be balancing the weight, strength, and electrical properties of the material to fit the required needs. Next, let's take a look at the raw materials used in the composites for these specific applications. For the fibers, woven carbon fibers are the most common material used. This is typically mixed with a plastic matrix, typically epoxy, to create the matrix material. These materials must meet performance requirements while also being cost-effective and easy to manufacture. Prepregs are almost always used for creating the battery enclosures. For structural batteries, multiple layers of different fiber types are needed. These include carbon fiber, glass fiber, and aluminum film. These layers are deposited in a structural battery electrolyte matrix. The fiber layers and electrolyte matrix are critical for giving the material its structural and electric properties. Next, let's take a look at the manufacturing used for some of these composite components. For battery enclosures, the prepregs are either made in-house or purchased from another company. The layers are pressed and cured, and a large variety of shapes and geometries can be made with this process. To the right, you can see a process used by TRB, a composites company that mass produces these large battery enclosures for public transportation like buses. In structural batteries, electrical fiber layers are pressed together and then layered with carbon fiber. These are then combined with the matrix material to create the final product. Now let's take a look at some of the advantages and disadvantages of composites in electric vehicles. These pros and cons focus mainly on the technologies discussed in the video already, but also apply to general uses of composites in electric vehicles. For the advantages, to start off, as mentioned many times previously, there can be significant weight reduction with the introduction of composites versus metal components in electric vehicles. Additionally, there's a lot of opportunity for volume and thickness reductions due to the smaller size needed to create strong products using composites. You can also increase the strength and stiffness improvements with the same volume and thickness if that's the desired traits. There's also increased fire protection, specifically in the thermal battery enclosures, as the composites can be tailored for this use. Additionally, improved thermal and environmental insulation greatly improves the battery packs. In all composite parts, there's a very big potential to reduce the number of components, which saves in cost, weight, and many other factors. You can also have the ability to tailor composite choices for specific applications and specifications that you might not be able to have with metal components such as steel or aluminum. Some of the disadvantages of composite materials are the raw materials are harder to source and store, as many times the prepregs need to be stored in cold environments. The manufacturing process is also more complex than typical metal manufacturing processes. This comes because of the relatively new technology with composites, but there's still a lot of room for improvement in the manufacturing processes for these materials. For some of this technology, such as the structural batteries, this is a very new field and a lot of further research is required before it can be used in mass production. Additionally, as with most composites, there is typically a higher cost associated with using composite materials over more traditional materials such as metal. Now, let's discuss the likelihood to market for a lot of these composite applications in electric vehicles. For the battery enclosures, several companies are already manufacturing composite enclosures for other car companies. The quantities for these battery enclosures currently range from very small to medium production sizes relative to the very large automotive industry today. As industry knowledge, efficiency, and demand increases, composite battery enclosures will likely rise in popularity. As for structural features that can store charge, this is currently a cutting-edge technology with a lot of ongoing research. There's still a lot of work to do to be able to optimize both the strength and electrical storage capacity before it's realistically marketable to the electric vehicle applications. The electric storage will need to outpace developments in traditional battery technology to be a viable option to replace the actual battery packs long term. In conclusion, electric vehicles and composites are actually more related and similar than you might think and have a lot of very promising uses for each other. They're both relatively new technologies that have the potential to disrupt traditional powerhouses in their respective fields, such as internal combustion engines and metal components. They're also both trending upwards in terms of advancements in popularity, with rising market share and cutting-edge technology being developed in both fields. They're also continuously impacting each other's innovations. As electric vehicles utilize more and more composites, the electric vehicles themselves are improving in fuel efficiency and capabilities. On the other hand, as more composites are being used in electric vehicles, car manufacturers and suppliers are coming up with more advanced and newer technology for manufacturing and creating composites. Both electric vehicles and composites have the potential to be game changers for environmental impact improvements in the automotive industry by reducing carbon emissions and improving fuel efficiency. The future is looking very promising for both electric vehicles and composites. Thanks for watching. Here's a list of references used for creating this video.